For chi-squared, we still have a certain alpha level. We'll stick to 0.05 here. We have our null and our alternative hypothesis written for us. So our state is done. Now we're talking about our conditions that we're checking, and we want to do random, but we also have a new condition called large rather than normal. And large means that our expected cell counts are greater than 5. And I should say at least 5 because it could be greater than or equal to. And the random needs to be as stated in the problem. Notice that this problem does not say random, so we're going to go ahead and assume that it's random. And then we're looking at our expected cell counts to make sure that they're all at least 5. And if you're not given your expected cell counts, you need to actually calculate the expected values and then state that they are at least 5. Well, now we need to get our statistic. What's our chi-squared statistic? So we need to take this data and we're going to enter 2 columns in our chart for the chi-squared in StatCrunch. So let's do that now. All right, here we are in StatCrunch. I've entered the observed values into the first column. I've entered the expected values into the second column. We go to Stat, and we're going to do a goodness of fit statistics here. It's a chi-squared test where our observed is in the first column and our expected is in the second column. Now, notice that expected could be just that we expect everything to be equal. So if we expected all of the M&Ms to have an equal weight, I could just click that and it would calculate for me. Now I click compute. We get our chi-squared value, our degrees of freedom, and our p-value. From StatCrunch, our chi-squared was 9.22. Our degrees of freedom was 5 because we had 1, 2, 3, 4, 5, 6 categories. And remember, it was categories minus 1. And our p-value was 0.101. Our p-value is not low. How do we conclude? All right, here's our conclusion. Since our p-value of 0.101 is not less than our alpha equals 0.05 level of significance, we fail to reject the null. There is not sufficient evidence to support the claim that, and here I just went back to the alternative hypothesis and wrote what was stated, that the color distribution for plain M&Ms is different from the distribution stated. Question number 5 is another chi-squared test. I encourage you to do your state plan, do conclude, and come back and check in. Finishing up on this last question, for our null hypothesis, we have that the distribution of blood types is 45% for type O, 41% for type A, 10% for type B, and 4% for type AB for Asian Americans. And this would be matching whites in America. The significance level we're going to use is 0.05. For plan, we have to assume that the data was randomly sampled because it's not stated, and then we need to show that the expected counts are bigger than 5. What we do is we take the sample size times the percent to find out what we would expect in 125 individuals, which are listed right there. In StatCrunch, you want to put your observed in one column, you want to put your expected in another column, and then you do, just like we did for the previous problem, you do a goodness of fit statistic, and we get a chi-squared value of 11.077, a p-value of 0.011, with our degrees of freedom being 3, because we had 4 blood types minus 1. Now, since our p-value of 0.011 is less than our alpha equals 0.05 level of significance, we reject the null. There is evidence to support the claim that the blood type distribution for Asian Americans is different than stated. And that's it for this module.